Imagine you have a list of student names, but some names appear again and again. You only want to store each name once. How can we keep unique values and also check them quickly? This is exactly where HashSet is useful. A hash set is a data structure that stores only unique values. Unlike a hash map, which stores data in key value pairs, a hash set stores only values. If you try to add the same value again, the hash set simply ignores the duplicate. One important thing to remember: a hash set does not store values in any particular order. It gives up ordering in exchange for speed. A normal list allows duplicate values. If you add Amit twice, it will store Amit twice. But a hash set does not allow duplicates. It keeps only one copy of each value. Internally, a hash set uses a bucket-based structure. You can imagine it like an array of boxes. Each value is placed into one of these boxes based on its hash value. When we add a value to a hash set, the value is passed through a hash function. The hash function converts the value into a number. Then that number is converted into a bucket index. This tells the hash set where to store the value. Let us add Amit to the hash set. First, the hash set calculates the hash of Amit, then it finds the correct bucket. If Amit is not already present in that bucket, it adds Amit there. Now, what happens if we add Amit again? The hash set calculates the same hash, goes to the same bucket, and checks whether Amit already exists. Since it is already present, the duplicate value is not added. To check whether a value exists, HashSet again uses the hash function. It does not search every item one by one. It directly jumps to the correct bucket and checks the value. This is why HashSet lookup is almost instant. Sometimes, two completely different values can generate the same bucket index. This is called a collision. For example, Ravi and Sara may both point to bucket 3, even though they are different names. When a collision happens, the hash set stores both values in the same bucket using chaining or a similar technique. When searching, it goes to that bucket and checks the values inside it, one by one, until it finds the right one. To remove a value, the hash set calculates its hash, goes to the correct bucket, finds the value, and removes it. This operation is also usually very fast. In the average case, adding, searching, and removing values from a hash set take constant time, which is O1. But in the worst case, if many values fall into the same bucket, performance can become ON. Good hash functions help reduce collisions. The main difference is simple. A hash map stores key value pairs. A hash set stores only unique values. In Java, hash set is internally backed by a hash map, but as a user, we mainly use it when we only care about unique values. A real-life example is event registration. If a person registers once, their name is added. If they try to register again with the same name or ID, the hash set can quickly detect that the value already exists. Here is a simple example. In Java, we use HashSet. In Python, the set data type works in a similar way. Both store unique values. One quick but important tip: these examples use text values, which work automatically. But if you store your own custom objects, you must correctly define their equals and hashcode methods, or duplicates can slip in. So, a hash set stores unique values and lets you check membership almost instantly. It uses hashing internally, performs well in most cases, and is perfect for removing duplicates. Just remember, no duplicates, no guaranteed order. And for your own objects, define equals and hash code. If this helped, subscribe for more visual explanations. Next up, hash set versus hash map.